The next demo we have is for the electric fields. So here is a plasma ball. There's plasma on the inside here. This is plugged into the wall where it's receiving electricity, and electric charge is building up at that middle sphere. You see at that center sphere where it's like the brightest hot pink color? That's where the charge is building up. But an electric field allows the force of the charge to act spherically all around at the center of charge. So it is acting on the ions, the charged ions within the plasma, to excite the ions and make them these awesome, cool colors. So here is your demonstration of the electric field. Again, much like the magnetic field, the electric field shows the forces that act between charged particles. So instead of acting between magnetic things, it's acting between charged particles, such as the ions within the gas. But also your hand, your skin has actually some charge to it as well. So it'll be attracted to that. So that's why when I put my hand here, we'll see that there's a force clearly acting on my hand from the sphere. So again, fields help us talk about forces that are acting at a distance. Now, without the plasma there, we really wouldn't be able to visualize the electric field. On the day-to-day, you can't see the electric field. It's there. For an example, this battery, it has charges within it. There's certainly an electric field acting around it, but we don't see it. But here, we can clearly see it due to the charged particles within the plasma, much like how we get neon lights as well. Another way that you can visualize it is with this PhET simulator that we used before. So if I take a charged particle and I put it right here, these lines are showing the electric field. Now, for a positive charge, they go outward. For a negative charge, they go inward. So an electric field actually just shows us what would happen if I put a positive charge right here. Well, the positive charge would be pulled in that direction. And alternatively, if I put a positive charge right here, what would happen if I put a positive charge right there? It'd be pushed in this direction. So the electric field shows what would happen if we put a positive charge right there. You can actually see how they interact with each other as well. So if I put two positive charges, we'll see that we have outward every which way. Within this PhET simulator, you can also see values and measure with a sensor the electric field. So right here, you can see the electric field is 14.2 volts per meter. Now, if I remove this charge, it's much less. It's 3.79, and only due to this one here. So an electric field shrink actually does have a vector component to it because it's representing a force vector. So of course it's a vector. And it also has a magnitude component where it is 3.8 volts per meter.